Today's video is in your Unit 1A packet on pages 10, 11, and 12. We are now going to be talking about identifying the number of solutions to a linear equation. The problem of the day page 10. I'd like you to do this by yourself. So basically you want to get x all by itself. This could be like 3x plus 6 equals 10. If you need help to figure out how do I get this x alone, follow the steps you would do with any two-operation equation. That's a hint for you. So go ahead and do page 10. We'll go over that in class. On to page 11, identifying the number of solutions to a linear equation. Again, this is in the 8th grade text of our series, Math in Focus. You can find it on page 104. We're in chapter 3, section 2 now. So far, the linear equations that you have encountered have had one solution. You get an answer, x equals 6, x equals 10 11ths, m equals 24. That's what's called a consistent equation. For example, x plus 4 equals 9 has one solution because you get an equivalent equation of the form x equals a or x equals 5 in this case. However, not all linear equations have one solution, as you're going to see. So try solving the equation x plus 4 equals x. Well, if you subtract x from both sides, you get no x's left in the equation, and you get 4 does not equal 0. That is not true. This is a false statement. If you get a false statement, the variable x has disappeared, 4 is not equal to 0, it's a false statement, then the equation has no solution. Sometimes equations have no solution. It's called an inconsistent equation. Tell whether each equation is inconsistent, justify your answer. So it won't get an answer. That's inconsistent. No solution, inconsistent, they mean the same thing. So here we go. We have, when I distribute here in number 1, 5x plus 15 equals 5x plus 3. Subtracting 5x from both sides, the x's go away, and I get 15 equals 3. No, it does not. Make sure you put that not through the equal sign. 15 does not equal 3. So tell whether each equation is inconsistent. Yes, this is inconsistent because this is a false statement. Yes, it's inconsistent. Justify your answer because that is a false statement. 15 does not equal 3. In number 2, 3x, distributing, 3x times negative 4, negative 12. 2x equals 2x minus 2. So far looking good. Oh, excuse me. Because I'm not going to be subtracting the same x's from both sides. It's not going to cancel. I'm going to get negative 12 equals negative, x minus 12 equals negative 2. Those don't cancel. These cancel. So x minus 12 equals 2. And adding 12 to both sides, I get x equals 10. Negative 2 plus 12 is 10. So it has a solution. So it's not inconsistent. So the answer is tell whether it's inconsistent. No, not inconsistent, because there is a solution. There is one solution, justifying my answer. Like we've seen in most of our equation solving so far. Next page. Tell whether each equation is consistent or inconsistent. Justify your answer. So justifying your answer. I have 7 times the quantity x, 7x, 7 times negative 3, negative 21, minus 7x minus 21 equals 0. Well, 7x minus 7x, it cancels, and I get negative 21, and negative 21 is negative 42 equals 0? Not. No, it doesn't. So the equation has no solution. And I'm just going to say EQ for short. Has no solution. Therefore, it's inconsistent. Five times the quantity x, 5x. 5 times a fifth, 5/5 is 1, equals 5x plus 3. We know these 5x's are going to both cancel. And we're going to get 1 does not equal, don't leave an equal sign there, does not equal 3. This equation, again, I'm just going to say EQ for short, has no solution. Therefore, it is inconsistent. Number 3, x plus a fourth, negative 4, 1/4 times 4x, that's negative 1x, and negative 1/4 times negative 1 is positive 1/4. So if I add x to both sides, because negative 1x is the smaller, I get 2x plus a fourth equals a fourth. Those cancel. And when I subtract a fourth, those cancel. And I get 2, and they cancel here too. I get 2x equals 0. Well, when I divide by 2, I get x equals 0. That is a solution. X equals 0. So it has one solution. So it's right on the side here, consistent. We get a solution. X equals 0. That is a solution. So don't be fooled by that. Consider this equation. Solve and see what happens. Well, I'm going to get 3x plus 5 equals 3x plus 5. Same thing on both sides. When I subtract my 3x's, again, they're going to cancel. Then I get 5 equals 5. Oh, that is true. That's a true statement. We haven't seen this yet. So what happens? The variables cancel, but the statement is true. So the variables canceled, and this statement, 5 equals 5, the resulting statement is true. Those numbers equal each other. It's not false. Try substituting different values of x into this equation. What happens? Okay, I'm going to pick x as 2. So 3 times 2 is 6. 6 plus 5 is 11. 2 plus 2 times 2 is 4. 4 plus 2 more is 6 plus 5 is 11. It works with 2. What if I put in a third? 3 times a third is 1. 1 plus 5 is 6. A third plus 2/3, that makes 1. 1 plus 5 is 6. Hey, fraction works. 2 worked. How about a negative? Negative 10. 3 times negative 10 is negative 30, plus 5 is negative 25. Negative 10 plus 2 times negative 10, that's negative 20. Negative 20 and negative 10 is negative 30, plus 5 is negative 25. Hey, that works. What happened? It always works. I tried 3 different kinds of numbers. It always worked. So this equation is called the identity. An equation that is true for any real number. What is it? An equation that is true. So you get a true statement for any real. The real number system, real number. It can be rational or irrational. You put pi into that equation, it would still work. Rational or irrational. Any real number will work. So tell whether each equation is an identity. So far we've seen one answer, consistent. No answer, false statement, inconsistent. And third kind, identity. So 2 times x, 2x, 2 times -1, -2, plus 3 equals 2x plus 1. Well, that -2 plus 3 is going to give me plus 1. We get the same thing on both sides of the equation. When we subtract those two x's, we're going to get 1 equals 1. So this, yes, is an identity because this is a true statement. That's a true statement. The equation has infinitely many solutions. Infinitely many solutions. Answers. So it, yes, is an identity. And the last one here, 6 times x, 6x plus 30 minus 10 equals 3 times 2x is 6x minus 9. 30 minus 10 is 20. So when I subtract the 6x's, I already put my 30 minus 10 together, I get 20. 20 equals, -9? No, it does not. Not. Put that not sign in there. Not. This is false. So this is not an identity. There are not infinitely many solutions. This is what's called an inconsistent. Not an identity. This is an inconsistent equation. And that's it for today.